This one is super easy. So in our insert method, after we set the height, we should calculate the balance factor. So we set balance factor to height of root the left child minus height of root the right child. Okay? Now, if balance factor is greater than 1, that means the current node is left heavy. So let's print a message saying root that value is left heavy. Okay? Else if balance factor is less than -1, that means the current root node is right heavy. So once again, we're going to do a print line, root that value is right heavy. Now let's test our implementation. So back to the main class. Here we have a right skewed tree because we're inserting these values in ascending order. So our tree is going to look like this. Now when we insert 30, 10 will become right heavy. Let's validate this. So I'm going to run the program. There you go. 10 is right heavy. Beautiful. What if we insert these values in the reverse order? So 30 first, then 20, and then 10. This time our program should say 30 is left heavy. Take a look. There you go. Now, to make this code more expressive, I'm going to refactor these expressions and move them into separate methods. Let me show you. So I'm going to add a private helper method, private boolean is left heavy. We give it an AVL node. Now here we're going to return height of node the left child minus height of node the right child greater than 1. That means we have more nodes on the left side, right? I'm going to create another helper method like this. Private boolean is right heavy with the same parameter. Now I'm going to copy this expression, paste it over here, and change this to less than -1. Now, as you can see, we have duplicated this expression in a few places. So now it's time to refactor this into a separate private method for calculating the balance factor of a node. So let's do that over here. Private integer balance factor. We give it an AVL node. Now here we have to check to see if node is null, then we're going to return 0 because an empty tree is balanced, so its balance factor is 0. Otherwise, we're going to return height of node the left child minus height of node the right child. Okay? Now that we have this method, we can reuse it in a couple of places. Here's one example. We check to see if balance factor of this node is less than -1. And similarly, in this other method, we're going to check to see if balance factor of this node is greater than 1. With these helper methods, we can simplify our insert method and make it more expressive. So first of all, we don't have to repeat this expression over here. We simply call balance factor and give it this root node. Okay? Now, instead of checking to see if balance factor is greater than 1, we can check to see if this node is left heavy. That is better. Similarly, on line 42, we can check to see if this root node is right heavy. That is better. So we're done with this exercise. Next, we're going to look at rotations.